So these are the data. Um, here are the data for the flat end of the cart hitting the force probe, and then here are the data for the spring end hitting the force probe. Got maximum force, impulse, and position reached by the high end of the cart after the collision. Those will be available to you. And here's what some of these things mean. Here's the ramp. This is the high end of the cart. This is the low end of the cart. The high end of the cart starts at the 2.5 centimeter mark on this centimeter scale that goes all the way along the ramp. So I let go. The cart is 19.8 centimeters long, so when it travels and hits here, it hasn't quite traveled the distance from 2.5 to 109.4. It's only traveled the distance from wherever this is to 109.4. So keep that in mind. Then when it'll hit the force probe and bounce back up, and what I have recorded is the height to which this part of the car reaches. So I let go of this, it goes boing, it comes back up here, and I record that distance. So again, this scale goes from 109.4 there to 2.5 here, and the length of the cart's 19.8. You're going to have to do some thinking and some math there. So those, what I've told you so far really just explains these three numbers: 51, 55, 56.5, and 73, 74, 74.5. Those are the positions reached by the high end of the cart when it bounces back up. Oops, went to the wrong place. Now, when the cart hits, I get a graph like this in Logger Pro. And from the graph, I can measure a couple of things. So this is one collision. This is a different kind of collision. This is what it looks like with the springy side. We've got a force, this force, which it gives me a negative number, but I'm just writing the absolute value over an amount of time. So you can see we've got a pretty good sized time, not a very big force. When the flat end hits, there's a much bigger force, but a smaller amount of time. So I can get the maximum force by just using my mouse. I can measure this distance and I can measure that distance. And then I get the integral, which is the impulse, which is the force, or the force times the time for each of these. And I've recorded it for you. So here we have the maximum force. These are all the maximum forces when the flat end is hitting. These are when the spring end is hitting. These are the impulses when the flat end hits. These are the impulses when the spring end hits. I think that's all you need to know. You're going to be filling out your own data sheet that looks like this. I apologize that this is so dark here. So you can copy my data into these cells and these cells, but you're going to have to figure this out and this out on your own. Maybe I should say a little bit about that. The linear closing distance would be the distance that the cart's traveling on its way to its collision. And the linear separation distance would be the distance that the cart travels on its way back up before falling again. So it's not going to bounce as high as it's not going to get all the way back to the end of the ramp. So the separation distance is going to be smaller than the closing distance. And from those two things, you're going to be able to figure out the separation, the ratio of the separation speed to the closing speed, so you can get the coefficient of restitution. I'll talk a little bit more about how to do that in class.